we'll begin today with Aaron from DOE, who's going to tell us about their tool and the most recent update that's going to be coming here in September. So Aaron, you want to take it away?
Absolutely. Hello, everyone. My name's Aaron Weimont. Pronouns are he, him. I work at the National Renewable Energy Laboratory, and together with the Department of Energy, we have worked on the low income energy affordability data tool, the LEAD tool. When Austin and I spoke a little before this call, he mentioned, I think some of you are familiar with it, so which is great. I hope to maybe show some other features that we have with it. And then at the end of towards the end of it too, I'll talk a little bit about the updates that we have coming up, and then hopefully answer any questions that you all have. So let me go ahead and start with sharing my screen. If I can find my presentation, there we go. Okay. Well, that's the last slide, so that's good. Can you all still see my screen here? Everything looking good? Wonderful. All right. So just to answer a couple of quick questions here, are questions about the LEAD tool. So some of the ideas behind the LEAD tool, we kind of discover, modify, understand, and create. So discover being we allow people to kind of look through and find the communities and the locations that they are interested in. Modify being allow people to adjust some inputs so that they can match some criteria that they're interested in. This would give them hopefully a better understanding of the energy usage or energy burden, or even just the housing counts in that area, and then develop programs from that data. So why was the LEAD tool created? We had, there was a program, this accelerator program that was called Celica, the acronym. Everything at DOE has to have an acronym. So this one got one too. It was aimed at lowering some energy bills for low-income communities. And then the LEAD tool was originally a set of Excel spreadsheets that you could kind of plug and play data with, where you could create some data sets that were useful for the programs you look to create. And then this was proved to be a popular tool, so we turned it into a web-based platform. And that's what we see today. So looking at the information that's in the LEAD tool, we have national, state, county, tribal, and city data. And the underlying data all starts at the census tract level. This gets broken down into a couple of different income models. Excuse me. So we have area median income and state median income, although for the most part, I believe state median income is the same as area for most states. And then we also have it broken down by federal poverty level. So we put these into larger groups. And so we have it from 0 to 100% of the federal poverty level. So that'd be people making approximately, I think it's $28,000 or something a year or less. Then we go to 100 to 138, and forgive me because there's 138 is significant in that process, but it's just escaping me right now. 138 to 200, 200, 400, 400 plus. So we have these breakdowns in there and kind of grouping the data in that way. Then we also have information based on the housing units themselves. So we have it broken down by tenure, whether it's a renter or an owner. We have the building of the year of the building was constructed, the number of units in the building. So that might be one unit detached, so a single family home, all the way up to 50 plus unit buildings. And then the primary heating fuel type. And you'll see a little bit more of that as we get into the tool. The outputs from this are energy burden as a percentage of the average housing energy expenditures to the income. So from our data sources, we have the income level, and then also we are able to and the energy costs, and so we're able to calculate energy burden based off of those costs. We have this as you see here for all the states, District of Columbia, Puerto Rico, and the tribal nations. So our data comes primarily from the U.S. Census Bureau's American Community Survey, and they do a 5-year average. So the current tool uses 2013 and 2018 data, And I'll get into this a little bit more at the end, but they recently released the 2016 to 2020 data. It takes a long time for them to actually gather all this data and then actually put it into a meaningful format that the rest of us can use. So the next update will include up to 2020 data. And then we do some calibration based off this. So after we collect the data we don't collect the data, but after the survey information from the American Community Survey is made available, we do run some calibration checks because it is from the survey, people are self-reporting their energy costs. And so we try to calibrate that and make sure that the energy costs reported in the ACS data aren't super far off from some of these other data points that we have. So with that was just a very brief couple of slides. I will jump right into a demo. I'll jump to that. It's on. There we go. Okay. So when you first arrive at the Lead Tool website, you'll just kind of be greeted with this little pop-up here that explains a little bit about the Lead Tool and asks you to pick an income model. So in this case, I'll just stick with area median income, but you can switch these at any point, which I'll show you. So it takes just a moment for it to load, but the first view that you come to is a view of the whole United States at the state level, including tribal areas. And then, as you might expect, you can navigate your way around the map and dive further down into each of these geographies to get a little bit more information. But just at the first level, I'll just keep it at the high level for a moment, but you can gather information, just quickly look at information about the states. You can also switch to one of the different output options that we have. So it defaults here to energy burden. And if you're looking at kind of all houses in the United States, this tends to have, on average, a pretty low energy burden. You can also look at our energy cost here. You just click between those to look at the different output options. And then same with housing counts. So in this case, housing counts is a little tricky because we're using tribal areas, and tribal areas tend to have pretty low housing counts. So might want to exclude those, remove those from the map, and then it kind of changes things around a little bit. So as you would expect, highly populous states, have higher housing counts from some of these surveys. Actually, I'll just excuse me. I'm so used to defaulting to Colorado. That is where I am, but I will actually go to Washington State, where all of you are. So if you're looking at the map itself, you can view counties, census tracts, or cities. And you can switch between these two as you want. As you jump into Washington State, you can just see all these main counties here. And again, it's showing the same data at the state level, but it's more broken down. Census tracts gets you even further down. Interesting, that's showing up twice. Small bug there. So you can also then view it at the census tract level. Again, you can look at the boundaries of tribal areas. Just note that sometimes they do extend across state lines. They don't necessarily all just fit within the bounds of the state. So you can show a tribal area outline. You can look at the outlines of the counties if you so desire, or you can just look at it plain. It might be a little easier depending on what it is that you are trying to accomplish. And with the map, I'm actually just going to remove these new features, the little notifications there. One of the other big features that we want to highlight here on the Lead Tool is all these filtering options that I mentioned briefly in the slides. So you can just add or remove any filters that apply to the data that you want to look at. So for example, if you are more interested in looking at low income households, then you might exclude some of these higher values here, and you're only looking at 0% area median income up to 80%. And you can see as you do that, the map changes to reflect the values. So essentially what's happening there is any household that has this higher income value is getting excluded from the results. And similarly, you can apply this to any of the filters that we have here. So if again you're interested in older houses, you don't want anything built in the last 20 years, then exclude that from your results. We also, as I mentioned before, we do have our heating fuel type. This is the primary heating fuel type, and it does get broken down into a couple different categories. Primarily utility gas, bottled gas, electricity, and fuel oil are the main uses. These other ones are certainly used, but the numbers just tend to be, there tends to be fewer households currently doing that. Building type also is broken down into quite a few categories. Like I said, we have 1 unit detached, like a single family home, all the way up to 50+ units in some sort of apartment building. Then we do also have categorizations for boat, RV, van, and mobile and trailer as well. And then the last category is renter or owner occupied houses. So depending on what you're looking for, you have, again, you have this the small filter here to look at those specific values. Let's see, I'll just add some of these back on just for our showing here. Below the map, we do have a chart that allows you to break down the data a little more in a little more detail. So in this case, because we are looking at Washington State, it just defaults to looking at it as a whole. But I'll show you in a little bit, you can actually look at different entities together on the map. But as you look here and hover over it, it just shows you a breakdown of the gas, electricity, and other, this one is defaulting to annual energy cost at the moment. So if you're looking at annual energy cost in Washington State for households that have 0 to 30% of the area median income, you can see the electricity, gas, and other costs. So that currently is the breakdown that we offer in the lead tool, is electricity, gas, and other. As I guess you might expect, people that have a higher income tend to have a higher annual energy cost. But then in the case of something like energy burden, again, unsurprisingly, lower income does, unfortunately tend to lead to a higher energy burden for these households. So again, you can just see the breakdown here of electricity, gas, and other for all of these as you go through it. The chart itself does have quite a bit of customization that you can do with it. So for example, if you have energy burden on one axis, you could have your annual energy costs on the other axis, and that will, you can kind of show those together. You also can break this down by different categories if you so desire. So I can instead look at area median income as the primary one. I could switch to one of these, or in the case of this, I might want to look at income also broken down by renter occupied and owner occupied houses. So this is showing the same data, but instead of just showing all the houses together, it's broken out by renter occupied and owner occupied houses. So with that, I want to jump now into some of the maybe more complicated features that the lead tool provides as well. So one of the things that a lot of our users originally wanted was to be able to compare two areas together. So in that case, if there's something if there's a census tract that I want to look at in a little more detail, I can come here, I can click on compare tract. Your comparisons right now show up on this left column as well. If you only have one item selected to compare, it will just default comparing it to whatever state you're looking at in this case. But then you can come down here and see Washington State and the census tract together in the same chart. So those get broken down automatically as you add them here. This is also worth noting. It's actually just a good example of this. Some of these I noticed to put a little bit of a red outline on them. And this is just to denote that the data from this census tract in particular had a very low number of survey responses. So it's just a little caveat to keep in mind as you're looking at this data. This doesn't actually come up very often. I just happened to find one that has this, but we can compare that to any other census tract that we want. Now we might want to do a neighboring census tract. So we can do that. And then we have both of these census tracts together here on the map, and you can see them all broken down together in their various categories. And then to get rid of something that you don't want to compare, like you don't need to compare these to Washington State anymore. Instead, you just break those down. Just remove that one, and then you can look at the data as is. Another feature with comparisons is I'll actually just select a couple of census tracts, and then here I'll just do a few more. I don't know, in this general Puget Sound area, I'll just select this one and this one. So one other option that you might have is, oh, sorry, just press the wrong button. Not what I meant to do. Seriously, I will do a comparison. Compare tract. Compare tract. And then let's see, I'll do compare tract and compare tract. So what I meant to click on was this combine comparisons option, where you can group things together into hopefully meaningful groups that you might need to use. So in this case, I'm just going to group my King County tracts together. And I'll just maybe call this like urban. And then forgive me, I don't know how rural some of these areas are, but just for example, I'll just call these rural versus urban. And if I save those and let this load for a second, now instead here, those values all get combined together. They're using a weighted average, and so they get combined that way to produce the correct calculations. And now you have urban and rural that you can actually view together. So you don't have to view 20 census tracts all at the same time. Instead, you could group some of them together into something that might be like a coastal region or something else that might be meaningful in your circumstances. Similarly, you can also group together all of the filters that we have. So in this case, there is a combined filters option. And again, this would just be into data groups that you find helpful. This could just be then, just group these three together and we'll call this low income. And then we'll group these higher ones together. The order of these doesn't particularly matter, it's just creating the group. We'll call this one high income. So now you see this breakdown of data by, in this case, we're looking at the low income groups by renter occupied, owner occupied, high income by renter and owner occupied, and then also broken down into our urban and rural combined geography regions that we're interested in. And this kind of gives you an option to create and combine any combination that you find helpful. You can kind of make them as simple or as complicated as needing to be as things get more complicated. Or as you add more entries to the chart, it might just become a little crowded, but if it's useful to you, that's totally fine. Oh, and just one other thing I do want to point out is you don't need to only group or compare something like a census tract to a census tract. You can compare, like if I go to counties and I just add in this whole other county here, I can compare that one. So I can compare these rural and urban census tracts that are grouped together to Stevens County as a whole. Same thing, you could do that with Washington State as a whole, or I could group Stevens County and Ferry County together and compare that to a group of census tracts if I so desired. There's not necessarily a use case for that. I'm not sure, but that's something you absolutely could do. And then, no, maybe not lastly here, but the other options that we do have is you can download both an image and the data for both the map and the chart. So this is just we'll just create a simple JPEG image of, oops, y'all won't be able to see that, but it'll create an image of the map. And then you can also just download the data for the chart, or excuse me, from the map itself. And that will be a list of all, in this case, you're looking at census tracts. So it'll be, or excuse me, looking at counties. So it'll be a list of all the counties and then the value of energy burden in each of those counties. So in the case of something like census tracts, you can download a list of every single census tract in Washington state, and in this case, its energy burden value based on these criteria filters that we have over here. And when you download that file, it will also list out at the top of the file all of the filters that were used to create it. So it does, if you need to download several versions of it or use different filters and look at different data, that's also possible as well. And as I mentioned, this does live below the chart as well. So you can download an image of this to put into a slideshow, or download the data as well. So the last thing I will just point out here, we do have just a couple of helpful links that about the tool itself. We have our email address that is shared amongst a couple of people, but you can always email that if you have questions or just ideas or concerns about the tool. And then I believe that I'll leave it there for the tool itself. The last thing then that I will mention is we do have some updates coming up, as both Austin and I have alluded to. In particular, we'll be updating the data for the LEAD tool. So as I mentioned before, that will be from the average of 2016 to 2020 data. We also are building a public API. So that will be more for developers, but it's a way for them to access all the LEAD tool data in a much easier way. So they can just do it programmatically and hopefully get the data that way into any other tools or spreadsheets or anything else that it may be used for. And we also will be open sourcing the code that is used to generate the LEAD tool data. So this actually could be something that anyone could create. So they could use this tool and say, I actually want to use a different income model. So I want to break it down by these values of income of $0 to $50,000 is category A, and $50,000 to $75,000 is category B. Those are the kind of things that we'll be able to do. And then kind of the biggest update is that we're doing a pretty major user interface overhaul that will just include some user features that have been asked for that we are looking to put into the new version of it. Also will include some other data sets. In particular, will include demographic data and educational attainment data. So that is, but that will be on a person basis, an individual basis, not on a household basis. It doesn't change too much. It's just that when you are looking at a map of the LEAD tool, you will also be able to see the demographics of those areas, and same with the highest educational attainment as well. We're thinking of potentially putting in transportation costs if that makes sense to add to the tool. We're trying to keep the tool kind of to its original purpose, which was to display this energy data and not necessarily overwhelm it with too many other things. But that will, all these features that I've mentioned will be available or planning on a September 2022 release of all of that. So I know that was a lot. I certainly want to give you all a chance to ask some questions. We can always save some time for the end as well if we need to jump on to anyone else, but I will pause there and let you all ask any questions.
Go ahead, Char.
Yeah, Charlie, thank you.
Yeah, thanks for the overview. This is fantastic and very helpful. I was curious does this tool show any like changes over temporal scales? Because it's based off of the 5-year data set. Like, can you see between, was it 2013 and 18, the changes of energy burden in a whatever geographic region?
We don't have that at the moment.
Okay.
But so part of that is this is the second iteration of data that we've put into the tool. Originally had data up through 2016, then we did up through 2018, they'll be up through 2020. But we try to improve the methodology of how we are calculating the data each time. I'm actually not the person that does the data calculations, but he also could answer any of these questions too. But so we don't do it from the previous data to the newest data because we kind of change things as we go along. But also for the 2013 and 2018 data, that's a really interesting idea. I don't know if the census provides it on a breakdown of this is 2013 and this was 2018. I think it's just slowly collecting the data over years is how they do it. So that's why it's 2013 to 2018. But I could look more into that too. I'm not sure, but we don't currently provide that in the tool.
Okay, thank you.
Yeah.
And Kim, you got your hand raised. Go ahead.
Yeah. Thanks, Aaron, for sharing.
You're welcome.
Put my hand down. Figured all these buttons. Okay. So 2 real quick things.
Of course.
So 1, can you address how you're going to handle? So you're currently using 2010 geographies.
Yes.
So can you explain or address how you're going to handle the 2020 geographies? And any data that's post 2019, how are you going to handle that?
Yeah, great question. So at the moment, the data will be up through 2020, so that still will match to the original 2010 census tracts. And the census tracts, actually, I don't want to misspeak here because I was talking to the person who runs the data and we were talking about the new census tracts because there were quite a few new ones. Like those did change quite a bit, but the way we'll do it is all the data we'll have will either be broken down into the pre-2020 new census tract changes data, or will be data from 2020 and beyond. So for this iteration, unless I am mistaken, and I will double check with our data person, I can get back to you on this, but it will be up through 2020. And so we'll keep the older version of the census tracts. One other change that I do want to point out that we are going to be doing on this tool is currently, as you can see, we don't really have an underlying map of like, you can't see a city underneath this. We are going to be changing that. So you think of it as having like Google Maps underneath it, and then we will overlay the census tract on top of those. So even if we're using maybe a slightly older version of the census tracts, you can still see some of the areas underneath it. But at this time, we're planning on keeping the older census tracts until there is enough data collected from the new census tracts to provide that. But I may be mistaken in that from the 2020 census, there may be enough data to move forward from there. Just last I heard, the census needed to collect data for longer to have it all be statistically significant. Otherwise, there was just too little data that had been collected. So I apologize, I don't know exactly off the top of my head when that's available, but yeah, either way, we'll be sure to clarify that in the tool itself too. But hopefully, go ahead.
And then just for clarification, all of your data is aggregated to the census tract. So we can't really identify numbers below the census tract.
Right, the lead tool does go up to the census tract level. I believe we start with census blocks, but that's just too much to put on a map. So we do it at the census tract level. And we will we're continuing that even yeah, we'll be continuing that going forward
Okay,
as well.
thank you.
But yeah, that's as small as it gets right now. Sure, of course. Great questions.
And Aaron, if we were interested in getting some census block data from you, could we do that? And
Well, that's a good question. I think this might more fall on the lines of as we open source the tools. I mean, it's just the code that gets run to create all this data. There would probably be an option for somebody to make some modifications to that and run it. And then in particular, if you're just running it, like we have to run it for the whole country, so it takes a long time. If you need to run it for a state or something, I think it's a couple, maybe like 2 hours or something, or I don't remember off the top of my head. So that would also be possible too, of, okay, I want to break this down a little differently. But I can get some more information on that too. So this is great. I love getting some new questions that I haven't had before. This is good.
and then another question I would have is like on the open source data, would you be able to make modifications to, the energy bills, et cetera? Would we be able to take utility data and plug that in to get more specific or more accurate data than what was pulled from the survey?
That's a good point. I don't think we plug and play in the code that we have currently, but again, I would hope, if it's available, the code would be available to anyone so they could take it and then say, instead use this data for this census tract or for this block of data. And that, that's the more accurate energy data that would be available. So I think it'd be possible, but it would probably require a little bit of work. And that's something, I would happily have conversations with people about that. I just may not be the one that codes it, is all.
Perfect. Thanks, Aaron.
Yeah.
Any other questions for Aaron at this time?
Great. Well, thank you all for going through that and asking those questions. And then I will hang around until we're towards the end if we have more questions there. Happy to answer them. And then also, like I said, the email address here at the bottom of the lead tool as well is a great one to reach out to if you have more, especially if you have questions specifically about the data. The other person I work with, his name is Uki Ma, and he has been at DOE for a long time and is very knowledgeable and happy to answer questions too. Because sometimes I don't want to misspeak about how he has processed some of the data, but he's quite knowledgeable on that as well. So thank you, everyone.
Thanks, Aaron.
You're welcome.
Excellent.
I think next on our agenda, we have Hassan to give us kind of a tour of what DataWorks has been up to. And I'll let you introduce yourself, Hassan, and your work.
All right. Thanks, Austin. So, hey, everyone. My name is Hassan, and I live here in Wenatchee. I'm a principal at Empower DataWorks, and over the last, let's say, about 3 years, we've been working with, I want to say 7 or 8 utilities in Washington on putting together these energy burden assessments. And the goal of these assessments is to help them report for CEDA Section 120, as well as to design or redesign their assistance programs. So today, Austin asked me to give an overview of what these energy burden assessments look like and what some of the lessons learned have been over the last few years.
We have Hassan frozen. It seems to be the case. Maybe he'll pop. He'll unfreeze here. But in the meantime, I wanted to thank everybody too for the questions that they have for Aaron. Those are really great questions, and help me, and I think help the group think through what the tools can and can't do. And even when they can't do something, it's not necessarily a bad thing of the tool. They're designed for different purposes and meet different needs. But of course, we're trying to figure out how they best serve Washington and Section 120. So it's helpful to kind of tease out those potential barriers.
Yeah, thanks for bringing that up, Austin. I do want to point that out. If you all have ideas or use cases, like I said, I don't know if the lead tool will be able to match those, but this is a tool for users exactly like you all. If it's not helpful, I mean, that's okay. But if it does end up being something where you're like, well, if you just tweak this a little bit, that would be great for us. That's fine too. I mean, we're happy to hear about all that. There's nothing wrong with you all saying like, this doesn't work. We want it to do X. Again, might be what we can accommodate, but always happy to hear those ideas and especially use cases and needs.
And we got Hassan back. Yay.
Yeah.
I'll have to talk to our broadband office about what's going on in Wenatchee.
Yeah. Yeah, I don't know, my internet dropped for a second there, sorry.
That's all right.
Where did you lose me, Austin?
You were just introducing the slide.
All right, awesome. So for CEDA Section 120, we want to get to some of these core numbers here. We want to understand how many high-burden customers we have, how many customers are eligible for programs. One of the core things we want to calculate is the energy assistance need, because that sets the targets in CEDA Section 120. I think the first target is utilities need to be serving 60% of the need by 2030. We also want to understand things like program participation and any gaps between the need and the available programs. So when we do a data exercise, we really want to be answering these 5 questions. I think of energy assistance data, you can really do it in 2 ways. So Aaron just presented one of those ways, which is going from the top down, thinking about things in terms of census tracts, aggregates. LEED does use that survey microdata for calibration, but in a general sense, it is a top-down modeling exercise. The other way of doing it is from the bottom up. So you try to gather as much customer level data as you can. Utilities have all of their customers' energy bills. They have information about their payment history, disconnections, arrearages. And now in this methodology, you're basically talking about adding in demographic information. So things are especially income. Because once you have income and energy bills in one place, it becomes a simple matter of dividing, and then you get to the energy burden. If you're doing it the customer level way, from the utilities, usually you will get, like I mentioned, this is the customer information system data. So this is monthly billing data going back for 2 or 3 years. Information about arrearages, late payments, program participation. So which customers have participated in which programs and how much in benefits did they receive. And from outside the utility, you're talking about gathering customer level demographics, sometimes data from community action agencies. They sometimes share demographic or program participation data. And then other auxiliary sources. So like the county assessors will give you a lot of information about the buildings and the building types. And the voter registration data is helpful to get at age, if that's a factor you want to consider in your program design. A lot of these are already things that are required in CEDA. So for example, conservation potential studies, most utilities over a certain size are required to do them. And with CEDA, utilities are required to report on program participation. And some of these other data sources are also public. Now, the exercise becomes, how do you take this big mix of data sources and try to put them all in one place? So that's really the bulk of the exercise. Because once you do, you have one data set where for each customer, you understand a lot about their energy use and their income and their energy burden. One note here is that where do the customer demographics come from? That's usually the first question that's asked. Well, customer demographics, they are usually purchased. So there are providers that sell customer level information, usually based on credit bureau data. And you can go out and buy these data sets. So they're not public, but they're commercial data sets. If you put that all together in one place, and here I just asked Chiharu and Lisa this morning if I could use their dashboard, and they said yes. So I'm going to share. This is Clark Public Utilities dashboard. A lot of it will look familiar. So a lot of it looks like what you would use the lead tool for. Where you're able to look at things like the building type, the age of the building, what kind of heating or cooling the building uses. You're able to look at demographics, so things like whether the customer is a homeowner or renter, their age group, what specific customer segments they're in, what's their likelihood of being disconnected from service. And then you're able to filter down and slice and dice and figure out a variety of different statistics related to these customers. Now, because this data starts from the customer level, so really you can look at it at any granularity you want. You can look at it at, right here, I just have it at the block group level. You can look at it down to the census block. You can look at it at the census tract level. Or you could even pull specific customer data. So an example of something like this would be if I want to say design an energy efficiency program. So I know these customers need to be homeowners, and I want to make sure that they live maybe in mobile homes. It's going to be a mobile home energy efficiency program. I'm able to filter down to that specific group of customers, figure out how many of them actually exist in Clark Public Utility Service Territory. So there's a couple of thousand mobile home owners in Clark Public Utility Service Territory. The map shows us where they live. I can tell that about 21% of them have a high energy burden. And about 9% of them have already participated in programs. And the level of energy assistance need for these specific 2,000 households is about $200,000. So all of this it's useful for program design, but really one of the primary reasons that we put this dashboard together is to help with these CEDA reports. So a lot of the numbers here you'll recognize if you've done the CEDA reports, you'll recognize that we really just pull them and plop them in the report. So things like what's the level of energy assistance need? So for Clark Public Utilities, it's about $10 million a year of need that they have. What's the level of funding? They currently have about $4 million in energy assistance funding available to their customers. We can also drill in and look at these things in a lot more detail by specific programs. So Clark is great because they have a lot of programs. So we're able to look at this. So for example, Austin, are you unmuting?
You're good. You froze for just a second.
All right, I'm back. So we're able to look at these performance metrics for the programs. So for example, we already looked at the need. It's about $10 million for Clark. There's about $4 million in funding. And we're able to see how effective the different programs are at targeting low income or high energy burden customers, just by looking at the program participation data. So for example, we see that we had a low income thermostat program, but only 16% of program participants were high energy burden. The rest would have been low income, but they didn't have a high energy burden. So what can we do to improve the targeting of this specific program? We're also able to look at what percent of eligible customers have been served by a specific program. So for Clark, looks like seniors are really good at accessing the senior rate credit. And LIHEAP is also looks like good penetration, but the rest of the programs appear lower than those two. Yeah, so in a nutshell, you put all of that data in one place and then you start building reports around it so that you're able to tell Austin and his team and the legislature everything they need to know. Switching gears to the top-down approach. So Aaron already mentioned, he gave us a good demo of the lead tool. There's other places where you can look at these more generalized data sources. So even lots of counties do needs assessments and landscape assessments. So you could often find those helpful. There's also, for this is for a client in the Midwest, which is a large utility, and they weren't at all interested in the customer level data. So they said, hey, well, they have 1.5 million customers. They're not going to go customer by customer and collect all of the data related to them. So what we did for them was something that I think Austin was asking about. This is a calibrated version of the lead tool, where we're using the customer bills from the utility. It could also work if they're aggregated by census tract or census block group. Then we're applying the same methodology as the lead tools. It's called this iterative proportional fitting algorithm. And the nice thing about doing it this way is that you get, it's basically all the benefits of the lead tool, but in addition, it's actually calibrated to a specific utility. So it can deal with really complicated utility service areas because you have the actual customer counts and the actual customer bills. And you get better estimates of your energy assistance targets because again, you're basing this on real data versus surveys. And you're also able to go down to a census block group, which is about 500 to 2,000 households usually. So it's a bit more geographically granular than just the census tracts. You're also, if you do this, the utility can then run it every year and keep the data updated because they have the energy bills are being up, they have the most up-to-date energy bills. So what do you pick? Do you do it top down where you're looking at census tracts and census blocks, or do you try to go bottom up, which is getting as much customer level data as you can? The compromise that you have to make here, obviously, is that the bottom up approach is very time intensive. It's a harder way to do things. So if all you need to do is just get a high level overview of energy burden, or get some rough estimates of customer counts and such, then I don't recommend doing a bottom-up exercise. With calibration, something like the lead tool could identify more accurate energy assistance targets. Without calibration, we ran some tests, and in some counties it can be way off. So I don't recommend of just using the raw numbers right away. But if you do a bottom-up exercise, really the benefits are in getting a lot more granularity with regards to specific programs, specific customers, being able to understand how you can optimize programs, how you can target programs, as well as this idea of identifying dispersed burden. So dispersed burden means that in many census tracts, energy burden could get washed out. If you have a lot of affluent customers, you might be missing the 5 or 10% of customers who do have a high energy burden if you're looking at it at that high level. But if you have the customer level data, you don't need to worry about that. All right. Some lessons learned. On average, in Washington State, for the utilities that I've looked at personally, utilities are funding anywhere from 40 to 70% of the need in their service area. It's higher for IOUs, so good job, Vista, Pacificor, and I don't know about Puget Sound, but I'm assuming it's the same order of magnitude. Lower for the COUs. The COUs hover at around 40% of the need is funded. On average, about 80% of those funds go to customers. So they end up in reducing bills for customers. And about 20% is spent on administrative charges and indirect expenses. And on average, about 40% of the program benefits flow to high energy burden customers. So the other 60% is flowing to low income customers, but they don't have a high energy burden. So this is telling us that there are opportunities, depending on the utility, there could be opportunities to improve funding, improve program participation, or improve targeting and how they reach high energy burden customers. Second lesson is that one size does not fit all. So because we're able to look at the level of energy burden and energy assistance need across many counties, it's clear that having this tied to a utility service area is hard. Why? So if we look at Mason County here on the west side of the Cascades, about a quarter of their customers have a high energy burden. So of their entire customer base, a quarter would really require assistance. At the other extreme is here where I live in Douglas County, and I think I saw Josh on the call, so in Chelan County too. We're talking about, it's a needle in the haystack. 4 or 5% of customers maybe have a high energy burden. There are counties like Yakima, where you have, again, close to a quarter of customers have a high energy burden, but Yakima County is part of Pacific Power's large service territory, and they also their service territory goes into California and Oregon. So for Mason County, those customers really represent a big chunk of their customers. For Pacific Power, it might be a small percentage of their customers that actually have a high energy burden. So putting all the onus on Mason PUD 3 or Mason PUD 1 to run programs to serve these customers, I think is a tall order. And it also highlights like the idea of having some sort of systems benefit charge I think would be supported by the data I've seen so far. Another lesson learned is regarding dual fuel customers. Electric utilities, if they don't run gas service for customers, they don't have access to gas bills. And depending how you look at it, so if you're looking at something like the LEAD tool and you're just capturing overall energy burden, not electricity energy burden, you could be overestimating what utilities have to do. And vice versa, if you're looking at the utility data and you're not taking into account that some customers also have gas bills, you could be undercounting the energy burden. Right now, what I typically go to is I say, okay, 6% is the threshold for all energy bills. But if you're flagged as a gas heat customer, we're going to use a lower threshold. We're going to use a 3% threshold for you. This is just based on how a couple of other states do it. New Jersey and Illinois have this separate thresholds for electric heat and non-electric heat customers. Another lesson learned is that there's a difference between technical energy assistance needs and the actual achievable energy assistance need. The more you become energy burden customers become like a needle in a haystack, the harder they are to find and the more expensive it is to actually go and target programs towards them. All of the data we can get, it only tells us on paper what folks' energy burden is, what the energy assistance need is. It doesn't tell us if those customers actually want energy assistance. It doesn't tell us if they would apply for energy assistance. So evolving our thinking to, sure, we understand our need, we understand we need to do things, but the reality is there could be customers who want nothing to do with utility programs or assistance programs. And understanding how that breakdown is, like who are these customers? Is there any hope of convincing them to participate? Or should we focus really on the low-hanging fruit, the customers who need it and want it? And finally, the kind of next evolution of some of this work is that there is such a thing as cost-effective energy assistance. If you add up all of the benefits that a utility gets from running assistance programs, so things like they can reduce their customer service staffing because they have fewer calls about late bills or high bills. They don't have to spend as much money on disconnection and reconnection staffing. Their debt write-offs are lower. Their arrearage costs are lower. If you add all of that up, and you are running a well-targeted program, you could actually see a positive ROI. So you could be better off running an assistance program than not running it. And the flip side is also true. You could be running a program where you're not seeing any return because it's not well designed. So thinking about how do you capture that concept that an energy assistance program can have a return on investment for a utility, I think that will help a lot of utilities also make a business case for improving and redesigning and even running new programs. And that's it for me. All right, back to you, Austin.
Thanks, Hassan, for the presentation. Do folks have any questions for Hassan? Hassan, one question I'd have is about that data that you're purchasing and like what's like a ballpark estimate of like what does that cost? Is that I know we've talked about it in person, but for the group as a whole, are we talking pennies or a lot of dollars, you know, for a piece of data?
It's usually of the order of a few pennies a customer. It's yeah, depending on what contract you have with these service providers, but yeah, I think Puget Sound would probably have a big bill, but for most utilities it won't be so big. Yeah.
And it's mostly the income data that you're buying.
Yeah, they usually provide other demographics too, home ownership and yeah, but I get it mainly for the income.
Okay.
John, you have your hand up.
I do. So Hassan, kind of following up on Austin's question, the purchase data, just like any other data, have some accuracy challenges in terms of timing when it's acquired and its precision, those things. What are you finding in that purchase data in the sense of how accurate is it, and do you make adjustments?
Yeah. Generally, so you can, if you go out and you just cut a check, you can get data for about 70-75% of customers in a service area. So first of all, it doesn't have full coverage, so you're missing about a quarter of customers. Now, the age of the data is another thing. So because it's collected based on how customers use credit, it could be outdated very quickly. So within a year or two, it could be outdated. The other challenge with it is that if an area like here in Chelan and Douglas County, there's a lot of development going on. So the entire neighborhoods could change within a few months. And again, the data lags that, so it doesn't capture that change. So overall, if you're using it for customer level, if you're using it for aggregate analysis, if you're saying, oh, what's my targets, it's great. If you're trying to use it at the customer level, I need to go target that specific account. I always recommend doing a second level of, you need to sanity check that this data looks right. And yeah, I think the last time I looked at it, I'd say like you can probably trust it to about, for about 70 to 80% of customers. and then you need to make sure you sanity check the rest. And sorry, and to answer your other question, yes, so we do impute, so we do fill in gaps for those other 25% of customers. Just looking at their neighborhoods and who lives around them, we figure that out. Yeah.
Hassan, one question I have, and I don't know if I can word it correctly, but so when I'm writing kind of an outline right now for the report that I'm going to share, that outline, and then of course drafts of the report with this team. And I find, when we have conversations as a group and talking to the utilities and talking to advocates and then looking at the statute, I find myself looking at things through the lens of the statute as it is, and maybe ignoring some other possibilities about how energy assistance programs are run, or what other data might be meaningful besides what's kind of requested in the statute. You covered a fair amount of that, I think, in the presentation, but is there anything when you look at the statute and think, oh, they really should have asked this, or why did they ask for this particular thing?
Yeah, I think, I mean, a lot of the things that are already in the statute, I think that they're useful, even if you can't get, the 100% accurate answer. It's at least helpful for utility programs to start thinking about these data points and targets, and there's actually an endpoint for assistance programs. You don't have to just run them forever, right? We are actually solving a problem, and so I'd say it's actually pretty good. To me, it seems pretty good. I wouldn't ask for any additional things, and then it seems like again, I wouldn't remove anything either.
Well, we'll make sure to highlight that part of the presentation for the legislature. So
Yeah.
Austin, the other Austin Phillips.
Yeah, I just had another quick question. Thanks so much, Hassan. That was incredible. I think I might have sat in on one of your talks last year at some point. So good to see you again. One thing that PSC is probably about to embark on is trying to quantify one of those, you kind of call it a widget in the calculus of reducing energy burden, which is the energy efficiency potential. Can you speak at all to how you went about that? How you would do that? Let's say you pick a customer, you can assume a broad range of how different measures would impact their usage. What was kind of your method for that?
So early, probably about three years ago, we made an attempt to look at the energy efficiency potential by measure. It was the idea is, first of all, you need to start by breaking up customers' bills into at least three components, right? You have your base load, your heating load, and your cooling load, and that's something you can do easily at scale if you have customers' monthly energy bills. Now, once you have those three numbers, you're able to start benchmarking them versus other customers. So you say, oh, I have this customer who's using he's at the 90th percentile of other residential customers in their neighborhood by cooling load. So maybe I should go convince them to do some cooling measures. So that exercise is very intensive, right? It's actually very similar to what behavioral energy efficiency programs do. So they start by breaking up the load, and they try to figure out which measures a customer would benefit from. Since then, I've moved to something much simpler. I just look at the energy use intensity, again, broken down into heating, cooling, and baseload intensity, and then benchmarking customers versus others. So what that tells you, again, is, okay, maybe it doesn't give you the specific measures a customer would have a potential for, but it gives you a general idea of who's a high energy savings potential customer and who's a low energy savings potential customer.
Thanks.
All right, and any other questions before we pass it on to the next speaker? Going once,
Right.
going twice. All right, Austin, back to you.
Yeah, thanks, Hassan. And thanks for all the questions folks had. We're going to have Kim from Avista give his overview of what they're doing on east of the Cascades. And but after that presentation, we'll do questions and then we'll take a 10-minute break. So before we move on to the final presentations. So Kim, take it away.
All right, thank you. Let me share my screen here. So this is going to be different than the last two presentations because I'm a practitioner. I work at Avista Utilities on our data science team, and I have been since about February working on how to address CETA and the CDIs and all of the metrics that go with that. So I don't have a PowerPoint presentation for you. I am going to show you some things that we built. This is kind of our approach right here. It's a little bit of science and a little bit of wizardry, and we hope to get an answer out of it. So I like this particular picture. Hopefully people are seeing that okay. I want to talk a little bit about some of the pros and cons that we've run into in the last few months working with the data. I'm going to talk a little bit about the tools that we're using and talk a little bit about the data. I'll try to keep it fairly short and maybe just address questions as opposed to giving you lots of slides. So in terms of talking points and things we've run into, probably one of our biggest issues at the moment is trying to stay consistent with geographies. I asked that question earlier with Aaron. So when we're talking about aggregated data and we're talking about census data and we're looking at large collections of people, we tend to do that with geographical boundaries as opposed to their individual characteristics. That's an important concept from a data perspective. And we're in an interesting time right now where those geographies, which have been very, very consistent, are changing. So the geographies, those census tracts change with every new census, and we've had a 2020 census. There are new geographies, and there are benefits and there's problems with using the new ones. It kind of depends on if you have a lot of growth in your service territory. It depends on if there's been a lot of movement. But we also are using a lot of other tools, a lot of government tools. And so far, most government agencies have not advanced beyond those 2010 geographies. So from a data perspective, we feel a little stuck with 2010 geographies and 2019 or earlier census data, because that once you get past 2019, census data starts to align with the 2020 census as opposed to the 2010 census geographies. So that's an issue when you're trying to use geospatial census tracts and use aggregated data from public sources. The next really big issue is energy burden definition. And Hassan touched on that briefly. Right, the RCW definition of energy burden is the total amount of money spent on energy divided by your household income. Both of those sides of the equation are not well defined. So energy burden, by definition, would include your heating and your cooling fuel sources. And I think in one of the RCWs it says, except you're supposed to subtract out anything that is used for electric vehicle charging. This gets complicated. In our service territory, we do serve electric and gas, but there's a large portion of our customers that use an alternate heating source, particularly if we start to move north in the northeast counties of Washington. There's a lot of wood heating, there's a lot of oil heating. So trying to calculate, the energy usage on that side of the equation is difficult. And then of course, income, trying to define income consistently is always difficult. Are we talking about salaries? Are we talking about investments? Do we talk about retirement? What is income? We tend to move to the census definition of median income. But then when we talk about federal poverty level, you're talking about household sizes. So that number moves around. So that's a difficult challenge for those who have to calculate these things without clear definitions from those that are asking for those measurements. Next big talking point, the data that we're dealing with potentially needs to outlive the transactional systems in which it lives. So we're looking at a law that extends well into the 2030s, 2040, 2045. Our transactional systems by design are not intended to live that long. So we can't simply rely on queries to pull this data and report it. We have to take this data and preserve it somewhere, because 15 years from now, we may need to report on 2022 data, and the systems that are in place 15 years from now won't necessarily be the same systems that currently house that data. So as we build our solution, we're thinking about that. The other thing that we're thinking about very seriously is consistency. So Department of Commerce, UTC, they're asking a lot of the same questions. We want to make sure that we're providing a lot of the same answers, regardless of which analyst in our company is asked to provide the answer. So making sure that we have a curated data set that can provide those answers, and that the definitions and the calculations within those data sets are consistent and can consistently be used by any analyst, whether they are new to the company, they're not at the company yet, that analyst 10 years from now that has to run the 2022 numbers. So we're thinking a lot about curated data sets and how to keep them consistent. The tools that we're primarily using, we're an Esri shop, Esri GIS. So we've created a base layer for our service territory and our named communities. I'll show that to you in just a second. We're using Oracle databases, although it's likely, as we think about the future, that we're going to be using AWS and S3 buckets and moving everything to the cloud. That makes sense for kind of future-proofing this. But at the moment, we're using Oracle. We're using Tableau to visualize a lot of our analytics, and we're also using some workflow tools to shape and curate the data. And then the primary data sources are our CIS system, our GIS system for our facilities. We are using census data. We have settled on the 2010 geographies because that's consistent with the Department of Health disparities map. And so we're using primarily 2019 ACS 5-year aggregated data. We are looking at third-party data as was addressed earlier. And I'll show you some numbers here that speaks to why we're looking at third-party data. If you want to get more, so with census data, you can have completeness. You can assign an income to all of your customers. That does not mean that you have accuracy. It just means you have a number from which you can do math. If you want accuracy, you have to do better than the census. And I'll show you some stats on that. And then we're also looking at disaggregated usage data, specifically to address things like the heating source. So trying to determine from our data whether the customer is using electric for heat, gas for heat, or some alternative fuel heat source. So I'm going to show you a couple things, and then we can get right to questions. So this is the GIS map that we have. So we've gone through, this is our Washington residential electric service territory. And we have the census tracts identified, and we have colored them in this case for the named communities. So that's what we're looking at here is a GIS feature layer that has our census tracts for our Washington residential electric service territory. So we use this spatial data. We then join it to our tabular data within Tableau. And this is kind of what we're building right now. And I'll just launch this. So this is a tool that I'm building. It's not built yet. But the idea is this is where our management, our leaders would go to see kind of what are, so these are the, I apologize for the yellow. I understand when I present the yellow, it's hard to see. It looks fine on my monitor. But these are the CBIs that we have. So I'm kind of keeping track of all the different things that we have to have metrics for. These are the equity areas in which all those CBIs lie. And then when this is all built out, I'll have a 3x3 grid for the equity areas, and you'll be able to very quickly just click on it and see the results for each CBI. If we want to see more detailed information, then we can dive in and anticipate that we'll have multiple years worth of data. We'll have other filters here if we want to get down into the detail of why a CBI is a particular way. So in this case, I've got burden by block group here. Both the number of households, so the total number of households in that block group, the number of burdened households, the median income, and you can see that the color indicates the greater burden. Interesting to note, this is our most burdened block group. Why is that? Because this is Pullman. So much like the DOE has discovered, when you do a survey in a college town, nobody has any money. So incomes look horrendous in college towns, but there's a lot of people living there. So knowing, one of the things we can do to normalize this is to use third-party data or census data to indicate whether or not the residents are actively in higher education. If they're going to college, you can then discount some of that information. We haven't done that yet, but it really skews the data to show that Pullman is a very highly burdened area. So we do run into data anomalies. The rest of this is just a bin, and this looks very much like the chart that Hassan showed of kind of where this is for electric. This is kind of where our electric bills land in terms of annual spend and how many customers are in those groups. And then we have, when we get, this dashboard is CETA related. So we also have things like outage incidents by block group, and how many customers are experiencing 3 or more outages in a year. So this is what we're working on, and the tools that we're using currently to produce this data set. So I think I'll just stop here and address any questions.
Perfect. Thanks, Kim. That's great. Any questions for Kim? And I apologize to Kim and the group. I should have also said that the IOUs, the investor-owned utilities, they have these customer benefit indicators is the term they use for their indicators of progress on vulnerable and highly impacted communities. The consumer-owned utilities do not use that term, but they do come up with their own indicators. And then there was another term that we used or we don't use on the consumer owned side. I'm blanking on it now. So yeah, but some different lingo across our different utilities, even in the state. Hassan.
Kim, this looks awesome, by the way. I like that you're bringing together these two big parts of CEDA, so the CEIP and then the energy assistance side.
Right.
In hindsight, what would you tell? What would you advise the folks who wrote the CIP? How should they frame their goals differently, or their vulnerable community definitions, for example? How would they make it more consistent?
So from a data practitioner point of view, not from a policy point of view, definitions and rules, right? When I'm dealing with data, I need to have definitions and rules. So when you tell me I need to calculate energy burden, I need a definition of energy burden. So if you say, well, that's total energy usage divided by income, great. There's a definition. Now I also need the rule. Like, what's the rule for energy burden or for energy usage? Is that if I only serve electric, do I only count electric, or do I have to go find the gas and the alternate fuels? What are the rules for the data? So, the RCWs do not have clear definitions or rules, and it leaves a lot up to interpretation, and data is nuanced, right? Not every customer looks the same. So it leaves a lot for us to do to comb through. The other issue that I have with dealing with the data is that concept of vulnerable populations and highly impacted communities. So highly impacted communities, again, this is from a data practitioner point of view. I have to be careful that I don't wear my corporate Vista hat too much here, because this is from, I'm not arguing that we should or shouldn't, I'm just saying it makes it difficult. Highly impacted communities are prescriptive. They were given to us, and they are at the census tract level based on 2010 geographies. That's a very specific definition and rule. Vulnerable populations don't have any of that. We were supposed to come up with our own. But when you start to mix and match levels of aggregation or types of classifications, so a highly impacted community is a geographically bound area. A vulnerable population doesn't necessarily share that. So that makes it difficult from a data perspective, to obtain accurate counts of when someone asks, well, how many of your customers that are in a vulnerable population have X? Well, I have to put some boundaries around that from a data perspective. So that's difficult. So we have chosen within our CEIP, we are currently using census tract boundaries for our vulnerable populations as well. I completely understand from a program or from a public need sense that that's probably not the lowest level we should be at, but from a data perspective, I have to work from something that I can be consistent with. I hope that answered your question.
Yeah, no, that's great. I'm also thinking of, because the definitions of vulnerable populations, again, they're a bit looser than highly impacted communities. What do you do with like I sometimes wonder, how much are we double counting, right? Like if we have 20,000 highly impacted customers and 20,000 vulnerable community A, 20,000 vulnerable community A, how many? We don't have the joint count anywhere.
Yeah, we did, because we have GIS tools and we have the tabular data. We know exactly where we overlap. So one of the things, I didn't show you a lot of pictures here. Let me see if I can find it real quick. So we do keep track. Oh, I was gonna I was going to show you that. Sorry, I was going to show you this too. Am I still sharing?
Yeah, we can see it.
Okay, okay. So this is a quick look. Let me see if I can make this a little bit bigger. So this is just a quick look at census median incomes and block group median incomes within those census tracts. And this is just our service territory. And what you can see is they vary widely, and they can vary extremely. So here's a census tract down here where the census tract median income is 58,000, right? Because one block group has a median income of 43,000 and the other block group within the same tract, 173,000. So this is where, if you only rely on census data, I'll have coverage. I can give a 58,000 income value to every customer in this block group, but I'm nowhere near accurate. I would show them as being highly burdened, potentially highly burdened, because as you mentioned before, higher incomes, larger houses, more fuel sources, probably spending more money. They would come out looking more burdened. And this is pretty consistent. We've got, here's another one with a wide disparity. So this is one of the things that we're learning is how accurate, do we need to be, and to be accurate, where do we get our data sources? So one of the things that we're doing for income is we actually have 5 levels of income. We have customer verified, we have program verified, we have customer matched with third-party data, block groups, and census tracts. And so it gets very nuanced when you're trying to be accurate. I was going to show one other thing real quick. And Austin, cut me off if I run out of time.
You're doing good.
Okay, so I got to just. What, I didn't color it, but it's in here. It is. Nope. Hang on, I'll find it. I got a lot of charts. All right. There's my burden households. Well, there's my named. So here's my named communities map. This is where we'll pull this up while I keep looking for my other one. Oh, it's over here. So here I don't know if you can tell, I've got 214,000 marks. So we've identified every service point intersected with our named communities map. So we can actually answer that question of the overlap. And then the other thing I want to show this real quick, is we went through, and for every single customer, and customer is another one that needs a definition, right? Because if I live in a house from January to June and I move and I live in a house from July to December, how many customers am I? Am I one customer or am I 2 customers? So we've gone with what we call a household definition. And this is every single household by their incomes. These are the census tract incomes, and we've plotted their energy spend against a census tract calculated income, and we normalized it for the amount of time that they live there. So if they live there less than a year, we've normalized the data. But this shows for every single customer a projected energy burden. So it can be done. Any other questions? I'll stop sharing.
This is Heather from UTC. Sorry, Austin, how much more time do we have to ask him questions?
Oh, we got time. We got time.
Okay. I think this was alluded to earlier, Kim. This is extremely helpful, by the way. I wish that when I started this position, someone had given me this presentation, but a year ago when I started this position, this was not all in process yet. So this is really great. CETA defines income level as 200% FPL and 80% AMI, if I'm getting that right. How does that make your life easier and or harder, I guess is my first question.
It could make it easier, except those are sliding scales, right? So both of those are based on household size. So the first thing I have to do is I have to either calculate every household size, or I have to determine what compromise I'm going to use. So we're probably going to use a compromise and probably look at county statistics or state statistics to say, what's the average home size? And then go with that number. Those numbers slide quite a bit. So if I look at an individual, if I'm creating a policy, or I'm trying to help a specific person, they're very, very useful numbers. If I'm trying to aggregate data across 250,000 customers, it complicates my life.
And another question, when you say, these are questions we're asking, these are things we're trying to figure out. Are these internal questions? Are these questions that you're internal? Okay.
Yeah.
So there's not, go ahead.
Yeah, so we've got, I've got the CBIs and I've got definitions of the CBIs. We have requirements that I didn't necessarily get to vote on. So now I'm trying to deliver answers to those requirements, as well as set up a repeatable process that collects this data and answers those questions over the next 15 years. Without necessarily making it an onerous manual effort. So yeah, a lot of our questions are internal. Like, what's a residential electric customer, right? That's not an easy question to answer, because we have many rate schedules, and within rate schedules, we have revenue classes. And so if I just look at an individual, right? If I look at a farm, farms are tricky. Is that truly what the state is after? Is determining that individual's burden, or should I throw that farm out because they have a $20,000 annual electric bill because they're operating, significant machinery, or we have landlords who own multiple properties, and the properties are in that landlord's name. They're not in the individual. Maybe they've rolled their utility bill into the rent. So we're not getting a true picture of who lives there. We're getting we get a picture of someone who has substantial means and substantial cost, but not necessarily substantial burden. So data is nuanced. The law is not nuanced, but the data is.
Following up on that, are you familiar with, so you made a point of saying, typically one way we look at data and for whom data is relevant is looking geographically. Otherwise, it's hard to aggregate, it's hard to visualize. Not sure if someone from PAC, Pacific Power, is on, but they did, in their CEIP, they did make an effort to say, in our service territory, here is the percent of our customers that have hearing impairments, for example. And they tried to do that with census data, ACS data, et cetera. Is that, I guess, what are the pros and cons of an approach like that in order to be able to say, we're not talking about one large named community entity in a census tract?
So again, I'm going to put on my practitioner hat and not my Vista corporate hat, because that's important. I think from a policy perspective, that makes a ton of sense, right? We should, if I look at who needs the most help, right? Because that's what this should be about, right? Who needs the most help? It's probably not geographically bound, right? That just makes sense. But how do I find them from a data perspective? That's hard. So let's take hearing impaired for a moment. Unless the utility asks all their customers, are you hearing impaired or not? I don't have that data. I don't know. So I have to rely on census data. Census data is aggregated. So I can say, well, in this census tract, so I can pull up a census tract. Let's just do that because that's fun. So I can say, in this area, I'm going to zoom in here for a second. So I can say in this area right here, I've got 953 customers, and the census can tell me that 4% of them are hearing impaired. So I might say, well, that's an important thing because for whatever reason, that's an important thing for me to track. So we could create a CBI that says we want to improve the equitable benefit for hearing impaired customers. That's admirable, but if I don't know who they are, I don't know if I've affected any change because I have to wait till the census comes out again to know what the number is. So my CBIs, I don't know how to affect change by doing anything because I don't know. I know they're in here somewhere, but I don't know who they are. So from a data perspective, it's difficult to try to narrow down. We're talking about some things. We've got some things that we're talking about internally about how might we identify vulnerable populations using some data that we could rely on outside of geographies. So there are some things. One of the things we kicked around is mobile homes. So mobile homes are highly inefficient generally, and generally we can find them, and because they do consume energy, we can compare them, and we can actually affect change with them. So that's but that's a structure thing, right? That's not an individual thing. So utilities find structures very easy to work with. Because that's how our data is built. We're built on infrastructure. So finding structures is easy. Identifying people is hard. We don't traditionally, over the last 125 years, really need to know a lot about people to keep the lights on. We have to know a lot about infrastructure, but not a lot about people. So we don't have a lot of people data.
Last question, I promise, Kim and Austin, I'm
That's okay.
sorry. Rewinding to the first question I asked was, who are you working with on this? Understandably, the nature of being a regulated utility is you get handed these things. I'm like, well, better figure out how to make this work. Are there ways that external parties could play a more supportive role in like, well, what do we do about this? And this doesn't even have to be a question you have to answer right now. And this might be something we think about more on the UTC side, but I'm definitely left with, is more input worse because you've already got enough going on? Or are there ways that there are best practices out there for this kind of thing? And it's just a matter of connecting y'all to the right people.
Yeah. So I don't know if I have a complete answer. I know that we have advisory groups. We have an equity advisory group. We're working with our equity advisory group, and that it helps because I sit here looking at data, right? I'm not actually looking at people. So it helps when we interact with people who actually are experiencing things. I'm not experiencing the same thing that they are. So my life experience is informed through data and through some knowledge, but it's not really informed through a lot of people. So it's good that those advisory groups exist and that we can talk to people. That helps. But at the end of the day, we still have to report data. And so data quality at the end of the day matters. And data quality on people is hard to get. So we are working, we air quality, where do we get air quality data, and indoor air quality, outdoor air quality? How do we as a utility collect that data, measure that data, make an impact on changing that data? It's hard. So I don't know what the answer is. I'm looking forward to the next couple of presentations here. Maybe they've got better answers than I do. it's not easy. We're trying. It's just not easy.
Thanks, Kim. Thanks, Heather, for the questions. Lauren, you got your hand up.
Yeah, hi, Lauren McCoy, from Northwest Energy Coalition. First of all, I just really appreciate that question, Heather. I think we too have sort of struggled to figure out how to provide helpful input on some of these questions. It's one thing to go through the kind of public stakeholder process, but to the extent that there are like discrete data access questions that utilities have, I feel like we don't really have a good forum right now for sort of tackling those collaboratively. And so, for example, I just heard Kim, asking about air quality data. And it's like, well, I don't know, I have some ideas about that, which I'd love to like talk to Avista about, what might be workable there. But it's been challenging, I think, for stakeholders to kind of figure out, first of all, what is the sort of box that we're operating within, right? Like these are the indicators that we're trying to tackle. And therefore, what data sources are available to us, and by us, I mean utilities, to help us kind of, assess progress on those issues. And it's just been kind of hard, I think, to do that within the CEIP process. And maybe it's the next, one of the next kind of steps that we can hone in on once we have some clarity around like what are the actual indicators that we're tracking, which I know Avista, has made a lot of progress on that. So, yeah, I was just weighing in to say, like, I think there are certainly stakeholders that are interested in trying to help answer those questions, but yeah, trying to figure out what those questions are so that we can provide the right input, I think is kind of where we're at.
Yes, I don't know if there's a question in there to answer, but I can tell you that we have been engaging lots of external parties we've reached out to research institutes, we've reached out to higher education, we've reached out to government agencies. So some folks do have data, but they have no intention of perpetuating that data. So that's a problem too, right? We have to be able to answer these questions repeatedly. So we need to make sure that when we get data, it's data we can count on for a while so that I don't have to go rebuild this every single time, funding for some program comes to an end and that university stops measuring really cool stuff. So one of my challenges is trying to both answer the question in the short term and design a methodology for long term. I don't want to be here 15 years from now. I don't want to be here 15 years from now. I'm going to be retired. So I need to design a system that can survive, generations of employees.
Thanks, Kim, and thanks, Lauren. I'd like to pick up on that kind of at the end of our presentations today. I think that would be a topic or a conversation to have a little bit more as we talk about next steps and our report that we have to send to the legislature. But for now, why don't we take a 10-minute break? We'll make it 12 minutes and go to 3 o'clock. So everyone has time to run to the restroom, get some refreshments, and then we'll get back together and start with Austin Phillips' presentation. So I'll see you all soon. All right, well, it shows 3 o'clock on my desktop, so thought we'd get started. Hopefully everyone got to stretch and grab a new cup of coffee and water or whatever your preferred drink is at 3 o'clock. So Austin Phillips, why don't you tell us a little bit about what PSE is doing on energy assistance?
Yeah, thank you all so much, and thanks Austin for having all of us. We almost match. If I had just worn my collared shirt, we would be a little indistinguishable. Always good to meet another Austin. So let me pull up the presentation that maybe like some of you. I'm actually not very. I'm not used to Zoom. We use Teams. And so I always have to make sure I'm pushing the right buttons and not doing something unexpected. Let me maximize everybody now. Okay, can you all see this?
Yep.
All right, that's great. And then let's do, we can't get to it. Okay. All right. And then, let's see. There we go. How's that?
Perfect.
So let me start off with, as many of you all have talked about, just kind of the different components of data that are foundational to all of the work that we've done. And I'm just kind of using the analogy of a palette of data. I probably should have made these different colors. It's a palette of all the same color, but the idea is that these are different subsets of data that we can combine, mix together to create new colors and kind of color our understanding of our customers. So let me go through these and then go into detail of how we've combined them and what that does for us, what kind of picture we're able to paint of the customer. So we have taken the approach, as some others have, or have at least alluded to the option of doing a bottom-up, as much of a bottom-up view of our customer data as possible. And part of the reason for that is that, again, as mentioned, when you go at a geographic level, you run the risk of homogenizing everybody. And you can't capture the details from one household to the next. And in addition, you can't really match up features that might overlap within a geography. So if you have, one neighborhood and 50% of that neighborhood has quality A and 50% has quality B, you have no idea whether 0% or 100% have quality A and B. It could be anywhere. So for that reason, we've tried where possible to get individual level customer data. So we use for income data, what I would just call our signature blend of, we're in Seattle, so we got to go with the coffee analogy, but the blend is between this third-party vendor data, and we get that from Experian, which makes up the vast majority of this income data. And then the other portion is what I would just call ground truth. So let's say we match our customers on Experian. That I think for us, we actually get around 88 and 90% match rate for income. But then we also have energy assistance programs, we have surveys, we have energy efficiency visits, and so on, where we've gotten actual reported estimates through the programs for customers' income and household size. So in those cases, that 10%, we would substitute the ground truth, which we would deem more reliable, for the Experian estimate. And we'll get a little bit later at how we've seen the accuracy of the Experian data unfold, because we've been able to measure that. And the spoiler alert is that it's mostly good news, But as you all have pointed out, that is an assumption, is that the third-party data is individual level, but it's modeled, so it has some inherent vulnerability of error. We also use the American Community Survey data for census block group or tract level to get different socio-demographic and economic features that I'm sure everyone is kind of aware of. Then for dwelling data, we use a third-party vendor that's in some ways the premise analog of Experian. So that gives us more information about the dwelling type, the year built, some estimate of the heating type, things like that. And it's called Atom with 2 T's. And then of course we have the PSE internal data. So that's what we think we actually know. This is the ontological holy grail that we actually know what their bills are because we're charging them. We also know their usage, their customer type, their past due amounts, and so on. And then of course, Aaron, thank you for starting us off with the lead tool. So we have leveraged that to mostly estimate, and we'll get into this, but estimate our unknown energy usage. So PSE has the difficulty that we are a kind of mixed service area utility. And so some of our customers, we know one of their fuel types, we don't know their usage on the other, between gas and electric and vice versa for other areas. And then in conjunction with groups like the Equity Advisory Group that PSE also has, we've attempted to gather other miscellaneous resources to help pin down that tricky question that, Kim, I'm so glad that you kind of expressed some frustration. We have no idea really how to quantify named communities, but we tried. We tried to go after some data that could inform that. So here, given that palette, is kind of how we mix it all together. For our income data, we have now kind of a productionalization where anytime we get new Experian estimates, anytime we have new customers enrolling in energy assistance or so on, or answering surveys, that gets updated in an income table. So that's kind of a primary color for the rest of this. Then when it comes to estimating energy burden, we need a lot of different components. So if we think about what is energy burden, it's just the quotient. So you have the usage divided by the bill resulting from usage annually, divided by the household income. So the income is a primary role in that. But then to get that tricky numerator, especially in cases where we have an estimate, let's say for a Seattleite, we know their gas bill. If they have natural gas, we don't know their electric bill, but we still want to be able to estimate their total energy burden from all energy sources. We have gone through a process of using these other 4 features in conjunction. I'm just going to bring this up with the lead tool to essentially, take the estimates from lead of total energy costs, gas, electric, other energy sources, and combine it with data from these different areas that essentially match a customer with the corresponding lead value. So in other words, we have a customer in Seattle. The lead tool will say, well, for a customer with these 6 characteristics, housing, tenure, AMI range, year built, and so on, we think their electric usage is this. So we take that customer and say, oh, we can get those 6 features, and then therefore read off from the lead tool what we think their estimated electric cost is. Bada bing, bada boom, there's their estimated energy burden for total usage. So that gets us to the second step. And then now transitioning into the other half of this. So we have energy burden, but then we have this charge to quantify and measure, equitability, as I would call it, for vulnerable populations and named communities. What we did here was take not only energy burden, but then inputs from, as I mentioned, our equity advisory group and these other data sources, some of which are geographic level, but other which we actually can get an individual level or household level estimate. And we combined all those to triage our census tracts into low, medium, or high. Uh-oh, it's starting to do weird stuff. Okay, there we go. Sorry, I don't like Zoom. Into low, medium, and high vulnerability. So that's our guess at how to quantify that, and we can get into it further certainly, because there is a problem of we might need a more consolidated definition, but this was our best attempt. And then finally, to identify named communities, we say, all right, let's take those census tracts that are either high or medium vulnerability, overlap those geographically with highly impacted communities from analysis through Department of Ecology and others, to get finally a set of named communities. And I think similar to Kim, what you mentioned, we're construing that to be like a geographic designation. So a customer is in a named community. They're not necessarily a named community customer or a vulnerable customer, but in virtue of being in that geography, we consider them to be with that classification. And then finally, I'll speak a little bit as to how we've successfully, or maybe in other cases with some frustration, tried to use these 4 outputs, whether that's using our income table to estimate our energy assistance eligibility for different customers, or using energy burden to track changes in burden over time. And so we're about to set up a system where we can track for each customer their change in energy burden from month to month as they get new bills. We can also use that to simulate the effects of new programs or different programmatic constraints, or even changes in energy rates on energy burden or total program costs. And then getting over into that second piece of it with named communities, the name of the game here is how do we then use that to define customer benefit indicators and ultimately be able to show quantitatively that somehow through various program action and strategies, we are trying to serve these named communities in a way that's proportionate to their need, and that we're not essentially replaying the effects of history and society and continuing to marginalize them in the way that they're served. So let me get a little bit into energy burden and how we calculate that. So here's our fun problem. So we have combo customers, electric and gas. We've got electric only, and then we have gas only. And so we would calculate energy burden a bit differently based on which type of customer. So these are the easy ones, the combo customers. We just take their electric and gas bills. But for electric only or gas only, this is where we would use that lead tool to kind of impute what we think their bill is. And the best analogy that I can come up with, it's a little bit silly, but it helps me remember it. If you remember in the original Jurassic Park, where they're telling how they complete the dinosaur DNA. So they have part of the DNA from the fossil, and then they have to substitute some frog DNA to kind of fill in the gaps. So it's like a best guess. It's not perfect, but it kind of creates a complete picture. So essentially our PSC bills are the dinosaur DNA. And the lead tool is the frog DNA here, but it's better than nothing. It says that we actually think the customer is using more energy, more money to pay for bills and to pay for the energy than just our own bills would reflect. This kind of gives us a better equitable view for especially these single fuel customers. This is kind of a look at when I mentioned how we match up the DOE values with an individual customer. So as you know, Aaron, you're well aware, and others who work with the lead tool are aware, it's not at the household level in terms of ability to look up an individual customer. So this is where we would use a little bit of Experian, a little bit of ACS, a little bit of Atom to say, well, for a given customer, we can estimate these 6 features. And if DOE tool says, given those features, we would estimate their gas and electric bill as this, then we would just propagate that across all of our customers based on these 6 characteristics. And thankfully, we're able to match 5 or 6 out of those 6 features for most of our customers that we did the analysis on. So I don't actually have any live specimen dashboards to show you right now, but I have a couple snapshots of dashboards. So next best thing. So this would give, for example, with energy burden, how we can map out areas of higher energy burden, lower energy burden. 6% is kind of the magic number for reducing below that, but we also looked at what we call severe energy burden that's above 10%. And so this is at the census tract level. And Hassan, I was trying to remember the term. I loved the term you used, but I can't remember it now. For essentially the idea that geographically, there's a masking of outliers. Was it dispersed?
Dispersed burden, yeah.
Dispersed burden. Okay, well, I did remember. And you're spot on. So the idea here is that if you pick a census tract randomly in the territory, the energy burden by household distribution is pretty much always going to be this, right skewed distribution where, yeah, sure, the median is around 2, but it's always going to mask these customers who are dispersed toward higher energy burden. So that's why, I would advocate that if you can get estimates at the household level, do, because it's going to unmask that geographic effect and allow you to at least pick up some customers who are in maybe a census tract that's overall doing okay, but they themselves are struggling. And this also allows us to intersect how is energy burden related to income. So for example, we saw if we plot the AMI percent level, so from 0% AMI, 20%, 40, and so on, and kind of cumulatively look at which proportion of the high energy burden customers have an AMI value less than that. So in other words, take all of our energy burden customers and say, where do they fall on income? We see that, the vast majority, so 96% of them fall within that low income designation of 0 to 80 AMI. And in fact, since it's kind of concave down, you can see that the lower income you get, the more proportionate that's made up with high energy burden. Let me kind of fast forward. Now, what this also allows us to do is, and this was mentioned previously, is okay, where do we go next? We can start to track changes in energy burden over time. So one thing we've done is compared like a 2019 annual set of energy burden data with a 2020 and see, for instance, here a plot of how, which customers have got higher energy burden or lower. and what are the properties of those customers? What patterns can we discern in it? And you can also think of it in terms of looking at the change, a change in energy burden is made up of either a change in the bill or a change in the income or both. And I won't get into it, but turns out if you take the log of the incomes and the log of the bills and the log of the incomes, this kind of divides up the space of customers into essentially those that their burden increased because of their bill or their income, and those that the burden decreased because of the bill or the income. So we're starting to, in other words, build out a scaffolding to understand how energy burden is going to change over time. Because as you said, Kim, this is it's not quite beyond the length of a human lifetime, hopefully, 20, 30 years look forward looking, but it's getting there, so we have to think of this in terms of how do we track things over a long scale. And this gets a little bit more at what I was mentioning about the change in energy burn. So very, very simplistically, this is sort of calculus with smiley faces, but you can think of energy burden as a bill plus the bad things minus the good things over income minus the bad things plus the good things, and here's where, Hassan, it gets at that question I was asking. How does this get impacted by, for example, behavioral change or energy efficiency change? So what we're wanting to do is take a look at as many of these factors as possible, or that are reasonable. We can't really predict global catastrophes, but it's part of it. And see, okay, what do we anticipate a change in energy burden would be with a different program or a different discount rate and things like that. So that, in other words, would kind of enable us to examine different scenarios. So if we had a scenario where we raise energy rates by this amount, but then we have a new energy assistance program and so on and so forth, we can compare different parallel futures in a way, and see how that will affect not only energy burden, but the program costs and the percent who are served, the operational efficiency, all those things, Hassan, that you've had in the kind of radial diagram, which I love. This is too much. I shouldn't have put that in there, but it's kind of looking at different scenarios and saying, for instance, okay, we could compare 3 scenarios over time, and here's kind of what we're seeing is that if we have that 2030 goal of meeting 60% of the energy assistance need, even that's going to be really tricky potentially with the programs we've got, much more so for the 2050 goal of meeting 90%. So this shows us, it at least showed me, that there's a lot of work to do in playing with different levers, essentially in that numerator of energy burden, to try and reduce it over the next few decades. Yeah, Kim.
So before we get too far, I'm just curious. So when we talk about energy burden, and again, from the data practitioner side, not from a policy side, if I have a customer who has a $10,000 income, and I can confirm that, and he's got a $1,000 energy bill, and I can confirm that, and we provide him with $1,000 in direct assistance to pay his energy bill, what is his energy burden?
I would say, using our calculation, that it changed from 10% to 0% between those 2 time measurement points. But that's kind of contingent on on like actually continuing to provide that assistance.
Right, but I agree with you. Okay, good. So in a time frame, so we're looking at our data in time frames, households in time frames. So if to calculate burden, I'm curious if other folks are doing this. I would like to subtract direct assistance from the bill before I calculate burden, in much the same way that I would like to add energy efficiency savings to their income before I calculate burden, because I think that's a fair assessment of what they are actually receiving. I'm just curious. We haven't done that. I have not done that yet, but I'm curious because to me that simple equation of they have $1,000 bill. I equate it to teenagers, right? All teenagers feel burdened, right? But the parents know if you're paying all their bills, they don't have any burden. So I'm curious what maybe the consensus is, or what maybe from Austin's point of view, how is burden looked at when there is assistance on either side of the equation?
Kim, I can take a crack at that. I mean, the way I think about it is that there's two numbers, right? There is the need. So that customer has a 10% energy burden. 4% of it exceeds the 6% threshold. So he has $400 in need. If you're providing $400 in assistance or $1,000 in assistance, you're more than meeting the need. So you're 100% towards your 2030 goal, essentially, for that customer. So I like to split them. I like to say, okay, this is their burden, this is their need, but then the performance of the programs is the assistance that's provided. So and that's separate. And you just have to compare the two to see how much of the need you're meeting.
So you wouldn't necessarily reduce the burden calculation. You would reflect success in the program.
Exactly.
Okay.
Yeah, that's a really great point. And then one tricky issue when, I mean, this can come up, especially in the light of the pandemic over the past couple of years. We've had a lot of customers that will report zero income, or even Experian will estimate them to have zero income. And so there's suddenly flashbacks of high school algebra is like, oh, their energy burden's infinite all of a sudden. But if you do a little algebra, you can kind of calculate or set a value for the energy assistance need that's just at maximum their total bill. So the EAN doesn't actually become infinite. It's just you would have to pay their entire bill in order for their energy burden to go to zero. Yeah, great questions. Any others before we go on a little bit?
Oh, we're doing good, Austin. We are at about 3:30. So
yeah, how much time do we want to save for discussion?
for discussion, and then we have John as well. I'm wondering, John, if because you're on the team, normally if we could have you present maybe another day, would that be a possibility?
Yeah, that'd be fine. Fingers crossed I make the next meeting, okay?
Yeah.
Some other crisis doesn't come up, but no, I'd be glad to do it. I've got everything stored and have been refining as other people have been talking, because I've been finding really good information. So no, proceed, but mine may not take that long too. So are we going to 4? Is that what the plan was?
Yeah, we're going till 4 and a little time for discussion. So
Yeah, if if Austin 2 is close or needs more time, like another 10 minutes, I think mine could probably be done really in a very short time frame. Okay, 10 or 15 minutes would be adequate.
okay.
And then and I'm happy to kind of zip through some of this a second, because I'd love to hear from everyone and have lots of time to talk. So one application more on the energy assistance side that we used our income data for was to essentially, in a calculated way, put a little bit of faith in our blend of ground truth and Experian data and say, we've got a lot of customers that are past due. Not all of them have gone through the verification process through cap agencies and all that, but let's pay off some of their bills. And so we did that this past December to the tune of quite a bit. And then but really the important part was that we actually surveyed them afterward to get an assessment of how many actually would have qualified had they gone through that whole process. And the answer was quite good. So 90% of the customers that we use this funding to assist were actually low income qualifying based on that Experian data. So, yes, there's some error associated with that kind of third-party income data, but for us especially, it was within tolerance of, it's at the end of the day, we just need to get these dollars out the door and help people, and so we're able to do that. And maybe this can be, a longer discussion, but essentially what we did at some other time, not right now, but what we did for trying to get the vulnerable populations, we got together a bunch of features. So energy burden, poverty level, percent of the tract with a disability, percent with fixed income, and so on. And we basically, for each tract, ranked them on a 1 to 5 for each of those features, and then just added up all those 1 to 5 values. And what you see is you have a distribution, kind of what you could classify as a total vulnerability score. It's just the sum of all those 1 to 5s. And the idea being that a tract on the higher end has more of those high vulnerability features than others. So this is essentially what we use to rank census tracts as low, medium, and high vulnerability, and then combine that with the highly impacted designations to get, so here would be our vulnerable population, kind of high, medium, and low map, showing you a lot of heterogeneity. And then you can overlay that with the highly impacted communities to say, here are where we think our actual named community geographies are, and then use that as a North Star to say, we've quantified this. We don't know if it's standardized yet, but here's a quantification of it. And let's see how that's reflected in our program enrollment, or where we're advertising, where we're marketing, where we're doing anything. So that's where we're at right now, is trying to use that with the caveat that we know that may evolve over time as maybe we have more clarity on definitions. So there we go. I'll stop there, and thank you all for sharing and making some space, and I'm very happy to answer any questions.
Thanks, Austin. Do we have any quick questions for Austin? And if not, we'll skip over to John and then kind of have our summary conversation. So John, why don't you pull up your presentation if you have something to show us. If not, just feel free to get started.
Okay, I'll give it a best shot. I wish I had learned all about this like 14 months ago when we were starting all this. It's amazing what we have seen. So I'm going to flip over my computer here just in a minute. I have like multiple screens going on, so I want to make sure I get the right one to share with everybody. Okay. Let's see if it will let me do it and share. And so hopefully you're seeing it. Can you tell me if you can see the screen?
Yeah, we can see the screen. We don't see a presentation mode, but we see the slides.
You do? Okay. Oh, great. Okay, excellent. So we're going to go from a little different standpoint, the non-data guy who is kind of the user and trying to figure out how to best reach our customers most in need to help reduce energy burden. And I'm just going to talk about one of the tools that we are utilizing and learning more about, and that's the City of Tacoma's Equity Index and how we're hoping to use it to implement enhanced energy burden reduction programs. So first of all, just a quick update on what it is. It basically takes data and details of the City of Tacoma area, and now it's been expanded into Tacoma Power Service area as well as Tacoma Water. And there are 29 key data indicators within 5 categories. And you can see them, they're like livability, education, environmental health, economy, and accessibility. So this is sort of a more broad reaching tool than just energy burden, but it's one of the many tools that we're using to help us make data informed decisions to improve access to opportunity for all community members. So this is just sort of a quick kind of effort of how it was put together. And I'm not going to take any credit for the put together, but just kind of tell you it's one of the tools that was made available to us. And you can just see the various data elements in those 5 kind of categories or attributes. And we have a City of Tacoma GIS team, Dakota Warren and Adriana Abramovich, and they collaborated with the Kerwin Institute and Community Attributes to kind of put all this together using a GIS system, which I will talk to you about here just in a minute.
And John,
yeah.
we are seeing your first slide. We are not seeing the other slides if you're showing those.
Okay, so let me try one more time. Unlike you guys, every once in a while, I have to try it again. So let's see if we can share. Apologize for that.
Oh, no problem. Can be especially difficult if you bounce from one system to another. Okay, we see the collaboration.
You see it?
Yeah.
Okay, all right. Unfortunately, multiple slides going on there. So again, this is just sort of the various attributes and the information that is compiled for this equity index. And I just want to explain to everybody, the equity index is not set up to say this person is low income and this person is not. It's about opportunities or access to services and programs. And it kind of is a broad scale brush or opening to take a look at that kind of canvas of customer and citizen or community member needs and looking at it from various areas. So just sort of to give you kind of a concept here. Hopefully this will work to the next one. And of course, it's not. Let's see here if that worked. Try one more spot here. Are you seeing the data sources okay?
Yeah, we are seeing it.
Thank you very much. Okay, so I just wanted to verify to you all that, you know, like many people, we utilize the US Census American Community Survey data for demographics. We also utilized in this data set that is using for the equity index, things like local data sources. We have crime and nuisance indexes. We have the urban tree canopy index. We have voter participation, assessor data, power conservation potential assessment information, when what homes have been weatherized. So a lot of different data sets were pulled together in this assessment. Some of the challenges that we're facing, and like many municipal utilities, our boundaries are irregular. They don't necessarily fit the census tract. And so you have areas where our service areas overlap with other utilities, or we may have a portion of a census tract. And so some of that had to be kind of prorated and GIS'd out to say these are our customers. Obviously, the multi-heating fuel types, a portion of our customers, and I'm one, happens to live in Tacoma, but my heating type is Puget Sound Energy Natural Gas. But I'm an electric customer for Tacoma Power. So we have those types of crosses, as well as the other fuel types that other people are doing, anywhere from fuel oil to wood burning, all those good things that happen. We have a large population of single family renters, which means they move in and out quite often. And so it's often to keep track of those customers. They don't necessarily stay with their location over a period of time. And there is that transition in our census area where people of higher income levels are moving into what have been traditionally a lower income census tract. And so that is maybe a good sense, a good thing of good improvements, but it also kind of complicates the data sets and our efforts. And I'm going to give you the other one is, no matter what you say, not all customers are attracted or interested in applying for assistance or programs. So we have to continually look at ways to do outreach and efforts. And obviously what I call the 600-pound gorilla in the room, and that one is COVID impacts, what that's going to do as we move into more efforts with our energy burden efforts and efforts there. So this is just a quick picture of the Tacoma Power Index. I'm going to demonstrate it here. It is broken down by the census tracts. And again, it talks about opportunity, and it ties in all those different attributes. But it does give us a good sense of what we can see. And in a minute, I will demonstrate this to you so you can get an idea that, yes, we can actually go down to the census tract and things of that sort. Okay. But I do want to let you know is that, you know, we've had a long history of low-income customer assistance and conservation since around the 1980s. And we're always seeking ways to enhance and target our customers. And so we're looking at all kinds of different things, from a zero interest loan program that we currently have had since the 1990s to looking at even forgivable loans as an option to help with rental properties. And so, like I said, we're really doing a special emphasis on rental property owners who are likely to have electrically heated homes in units. So what I'm going to do here is I'm going to stop sharing for a sec. And then I am going to get you into the actual assessment tool. And my fingers are crossed, Austin, that this will be visible to you guys. And I think I see it. So we're going to give it a shot. Hopefully it will work.
I see it.
Do you see it?
Yeah.
Okay. All right. I got, again, unfortunately, multiple screens because I've been doing business in between as life doesn't stop during a presentation. Okay. So this is the actual site where the index is. It can be adjusted based on a number of factors. You can come over here to livability, accessibility, all those things. And it is broken down by the census tract. And I can come in here and I can draw an area as an image in here and say, I want to see that, and it will come down to the demographics and other attributes of that site. This is going to be interesting if it will let me go back to this. It will. Okay. I'm hoping. Come on. Takes a sec. There it goes. It's coming. It takes a minute to just to wake up. Okay. So again, as it loads back, this is the city of Tacoma boundaries, but I also have the option to look at it from Tacoma Power service territory. And you can now start to see that situation of the irregular boundaries of our service territory. And you can see that there are more options in here. So I can blow this up a little bit and we can get it into whatever area that we want. And again, it is a tool for us to take a look at the census tract, to take a look at where our economy issues are, where we can maybe focus on some of the things that we're working on. And one of the topics that we're starting to look on is we're looking at overlaying where we have done work in the past on the census tract and actually going hopefully to the census blocks eventually here to actually see where we've done work in the past and where we could do work more, tying it with our conservation potential assessment. So rather than having this kind of number out in there, we actually can have sort of a geographic reference of where we could target sites. So as I said, for years, we have looked at ways of using social media, print media, and other ways to reach the audiences in targeted areas. And this might be the tool that could help us do a little bit more. I was very intrigued by the lead tool, did not know much about it until today, which is, those are what we're supposed to do, is learn about new opportunities. So thank you for that. But I just wanted to kind of express that there are a number of tools that you can use in your community or in your county that can look at different sources. And it may not focus just on energy burden, but other resources. And this one just gives us a tool to tie in with the data we have from other sources, our customer data, and other things that can help us maybe focus and target and enhance those areas of least opportunity to help them reduce their energy burden. So this is just, as I said, a quick user's tour of how we did this. So I'm going to stop sharing and go back to the screen. So like I said, it was just a quick goal. Okay.
That's perfect. Thanks, John. That was really helpful.
Yeah.
Kim, you got a question?
I do. Am I unmuted? Yes. So John, thanks for that. Two questions. One, who funds that study? And two, how long will that study be funded?
Okay, so this was an initiative by the city of Tacoma. I don't have all the funding sources, Kim, at this point, but it was a direction of the city council in response to our efforts to be more equitable, and a direction from the city in a resolution to do this. So this was an idea to pull all this data that we've all had for years and pull it into one location. So it is intended to be an ongoing project to move forward. Okay. How it was initially funded, unfortunately, I don't know. Okay.
So you have access to some of that data just by nature of how you're organized, not necessarily because you guys funded it or participated in.
Correct. Yes,
okay.
Exactly.
Well,
how
they
they initially worked with community attributes and the Kerwin Institute in funding this, I don't have the answer. I can certainly find out for you. But again, I saw this as a tool when we were learning about energy burden and trying to figure out our next steps to do the assessment, as we started thinking about what tools are out there already. And in the works, one of the things we've been doing is looking at our conservation loan program. And when we moved to the 80% AMI, that changed a lot of things. Suddenly, more of our customers were eligible for zero interest loans than had been in the past. And we have a deferred loan program for those customers. So it's sort of like suddenly our population of opportunity went from, a certain number to just a larger number, which we were at first were a little scared about, but in the other sense, we thought we looked at it realistically from a budget standpoint and said, you know what, we can do this if these many customers are there. And when we made that concept, we went to our utility board saying, if that response, which we think will happen, happens, then we may have to come back to you for more resources. So I
Thanks.
hope that answered your question.
Yeah, it's just a nice resource for you guys.
Heather, you have a question?
This is probably unfair, John, but okay.
Go ahead, shoot. What the heck? It's
Great.
the end of the day almost.
If you had sort of 3 points, you're telling the utilities like, oh my gosh, how do we help rental customers with energy efficiency in our service territory?
Mhm.
What do you tell them in like a 3-minute conversation?
I'd say that the key thing is the property owners and identifying them and engaging in them in maybe new ways. Most of the people, when we have done focus groups, have told us that, you know what, I don't have time to worry about this. I just really am trying to keep the house together. I want to make sure the rent gets paid and they're safe, those types of things. They're seeking assistance to help them get through all the paperwork. And so that's sort of that concept of us being able to do maybe a more one-on-one engagement with property owners to help them do it. So that's probably the number one thing, is how can we reduce the documentation requirements, which can be very tedious, and in some cases concern about privacy for customers, you know. So that would be one, is engage the property owners and help them reduce the documentation needs. The second part is to try to figure out a way to basically eliminate owner contribution, to make it as clear cut as it can be in some way or another. And that's why we're kind of looking and pursuing a forgivable loan program. If they proceed, they keep the rent affordable, then for a period of time, we forgive a portion of the loan over time. And if they can do it for a 5-year period, the whole loan could be forgiven. So we're trying to make it attractive and basically reduce out-of-pocket expenses for them as much as possible. And the last one is what's the carrot? How do we get them to do it? Right now, we're trying something that involves the key thing in conservation, and that is weatherization. It's the greatest measure, greatest savings amount. We're going to make it free. And so we're basically going to cover those costs for qualifying properties. And the hard thing is when you talk to customers, whether they're property managers, property owners of rental properties, or their own self, the one thing that isn't sexy is weatherization. Okay. I just don't think insulating the house is as sexy as a heating system. But if you tie it together and saying, hey, if you want to improve heating, water heating, insulation goes along with it. And so we tie it together with that concept of the forgivable loan. I hope that answered the question.
Nicely done. Thank you.
You're welcome.
Thanks, Heather and John. Hassan, do you have a question specific to, for John and data, like a data question or?
Yeah, John, I was wondering, I mean, your the Tacoma tool is the only, well, aside from LEED, it's the only public tool that we saw today. Have you found that other entities other than City of Tacoma are using it, like customer advocates, or in your for the CIP, the stakeholder engagement exercises?
It was developed to be broad-based and used anywhere into the Tacoma area. And I'm not sure I can give you a very clear answer on its usage, but I do know that advocates and other organizations have taken a look at the tool, have used it, and provided input in there. So I can't tell you yet on the usage, but I can certainly find out, Hassan.
Perfect, thank you.
So with our, we got about 6 minutes left, and it's not enough time for a real ample discussion. So we'll come back to that as the advisory team. If you have questions today for any of our presenters, feel free to send those to me, and then I can put those in a list for folks, and they could maybe give us a response, and I can share that with the group so everyone has that information and the types of questions that folks are asking. One question I have kind of today, and we've seen a lot of great data tools. Every presenter has presented a great tool. And then when we go back and we look at the reports, we have a lot of folks who don't have either the staff time, the resources, the data to pull this together at the utility level, either to hire a contractor, do it in-house. And then the other thing that I think about is that the state itself runs a bunch of low-income programs, from food stamps to other programs through DSHS, and sits on a fair amount of data. Obviously, that data would need to be cleaned, and it might not be organized in a way that's usable at this point. But you'd think that if we were running the food stamp programs and others, that there would be a set of data that could be mobilized to help those folks. I'm wondering, because we have the two of you today, Austin and Kim, if you have any thoughts on, for those folks who might not have, that are utilities that don't have resources, how they might, how we might help them, or any of that state data, would any of that be of use? Or would an exercise in trying to create something for those communities or for the state as a whole just be too big of a task?
I'll take a 1 minute shot. I think the lead tool is a good start. I think it depends on the level of aggregation and the expectation of the reporting. So, if you ask, what percentage are experiencing something, that can be done with aggregated data. If you say how many, I need to know my customer counts. So it depends on how you expect things to be reported, and what your expectations are for change, right? Are you expecting a percentage change, or are you expecting to see a number of customers impacted? So yeah, I don't have a great answer for you, but the lead tool is a good start. Tacoma's tool is pretty cool. It'd be nice if all cities had that, but we don't have that in Spokane.
Yeah. Thanks, Kim. Austin, do you have any quick thoughts? I know I gave you a big question right at the end.
Yeah, that is, I'd say the $1 million question is, how do we make a tool that serves all the purposes that we need and is easy to use and gets us to the granularity of information that's necessary? I mean, it's just really inconvenient that energy burden is a ratio of 2 features, because if it were just one customer feature, you wouldn't actually have to go down to the individual level to track it. But it's that synthesis that makes it a little more complicated. So I agree with Kim. I think the lead tool is a great start. And in terms of actual efficacy, even if you just target areas geographically that have on median a higher energy burden or energy need, all else being equal, yeah, that's going to be effective. So it is a great information game, and I hope that more utilities are able to use that as a starting point. In some ways, it also speaks to utilities are in a transition as a whole toward needing to be really data science driven, and for companies to be able to have funding for folks who can spend a lot of time to play around and model and do these things, because now we kind of have to. I think that's a good thing, but I hope that really the industry moves more in that direction, where there's recognizing a need for for quantitative minded folks.
Well, thanks, Austin. That's I think, a good place for us to end. I want to thank everybody who came today and presented, and for all the good questions. For the advisory team, we will pick this conversation up and have more time to digest it all at a future meeting. So if you have thoughts right now, I encourage you to take up your pen and pencil, or take a Word document and type out some of your observations today, and so that we can revisit them in the future. Again, much appreciation for the folks who came and spent 3 hours with us. It's a lot of time. I really appreciate it. And it was a lot of great information for us. So thank you all, and have a good rest of your week. Bye now.
Thanks, Austin.
Thank you, everyone.
Austin.
Bye.